Welcome back to part 2 of the dental scrap refining and recovery series. We're going to begin this part of the video by filtering our solution. Let's get a standard test on this, just as a baseline to see what we got going on in this solution. Can't really tell. I see a little bit of green outline at the very tip of that. So we definitely got palladium and probably platinum in our solution. And the longer you look at it, see how it's turning green up there? That's an indication that we've got lots of palladium in here. Here's our test. You can see by that color, green is palladium. So this solution is going to be loaded with palladium. I'm going to add a little bit of ferrous sulfate to our spot plate again and do another test to see if we've got any gold in our solution. Let me get a little bit of our solution in a pipette. Add it to this ferrous sulfate, just get an idea and see if we've got any gold in here. I can't really tell. So now what we'll do is I'll get a little bit of this solution, just a drop of it, stick it in this cavity. Drop. I'm going to use some distilled water and just barely dilute this. I will add some ferrous sulfate to that dilute solution and see if we can pick up any gold in there. I don't really see a whole bunch of gold in there. So I'd say the conclusion of this test is that our solution has very little, if any, gold in it. What's left in the bottom of our beaker, little pieces of metal. It's very difficult to get platinum to dissolve in Aqua Regia. Just about got everything pulled through the filter, and we'll use hydrochloric acid to rinse the filter out. Here's another look at that stannous test. The green means palladium, and then down in here there's a little bit of orange, which indicates there's some palladium and platinum in this solution. Here's the 3 pieces of metal that were down in the bottom of our beaker. I'm just going to set these aside. I'm not going to try to go after this with more Aqua Regia. We'll just throw this in with our next batch of platinum group metals. I've almost got this all pulled through the filter now. I'm going to prepare some DMG. I've got some hot water in this beaker. Got some DMG in this little flask. And I think we'll be able to get away with dissolving the DMG in this hot water. DMG does not dissolve well in water, but I think we'll be all right. Here's what's left in our filter. That could be rhodium or iridium. So what I'll do is I'll save it in this little container right here later on, but for now what we're going to do is just move it out of the way Transferring our solution that has our metal in it into a clean beaker. Now what we're going to do is add the DMG to our platinum group metals and precipitate out the platinum and the palladium. Here we go. Let's go ahead and add this right on in. Here we go. Here's our precipitate and our solution. But I can tell by the color there's still plenty of platinum metals in this solution. So what I'm going to do is I've heated up some more water. I mean, the logical assumption is to just add some more DMG in here and continue the precipitation, but a lot of times when it comes to platinum group metals, sometimes that's not always the solution. This is some DMG, more DMG that I'm going to add to this beaker. Full of distilled water. Stir this up. Now let's give this a shot. I've got some more DMG dissolved in a little bit of hot water. I'm just going to add this right on in to our platinum group metals in solution. See if I can get any more precipitate to form by adding more DMG. I added that extra amount of DMG, and I can tell there's a little bit more precipitate now. I'm going to get some of this solution on a piece of filter paper, and we're going to check this and see how much metals we've still got in solution. Still got some metal in solution, but it is getting lighter. Got some more hot water here. I'm going to put in a couple of measures of DMG. I don't have a lot of experience with this precipitation, so I'm not exactly sure how much this is going to take. Platinum group metals in solution here, and see if we can get some more of it to precipitate out. Here we go. Notice that the color in here has lightened up and turned a green color. I believe that's because now that the platinum group metals that were dark brown, reddish color have been precipitated out into that precipitate down there, what we have is a light yellow colored solution, but it's probably got some copper in it. And yellow plus blue, copper in solution is blue, so yellow plus blue equals green, and I think that's what we're seeing, why we have a green solution there. You can actually see through this solution now, and that's a promising sign. I believe that's because we've got all of the platinum group metals precipitated out. So now what we're going to try to do is strain out or filter out the precipitate out of this liquid. We're going to gather the precipitate in this filter, and the liquid will be a waste solution. I'm going to get a stannous test on this liquid in here and just see what we've got in solution. Just a touch of metal. Not real dark like we had it earlier in the process. So all the, not all of it, but most of the precious metals has been removed by the DMG and is in this precipitate in here. This is going through this filter very quickly, which is another good sign. I'm going to get a sample of this liquid. I've got some 10% ammonia here. Regular old grocery store ammonia like you clean your kitchen with. I'm going to get some in a pipette here. If there's any copper in here, when I put this ammonia in, it'll turn blue. And I don't see any blue color in there. That's a good thing. I've got another pipette full of ammonia. I'm gonna put that in here. I do see a little bit of blue color forming in there. See that? Here's our funnel with the precipitate in it. I'm gonna move it over here onto this beaker. Now what we'll do is commence to rinsing this precipitate off real good with some distilled water. This will go in my stock pot. It's going to have a little bit of platinum group metals in it. I'm going to transfer the precipitate into this beaker. Put our precipitate up on a heat source here. Now what I'll do is add some hydrochloric acid. I'm going to throw a stir bar in here, cover it up, turn the stir on. Now what we'll do is start adding small doses of nitric acid. And we're going to redissolve our precipitate in here. And this stuff is very notorious for wanting to boil over. So I got to be real careful adding the nitric acid in. I got to add it in real slow here. I've had this stuff boil over on me and come up out of the beaker before. I'm going to add a little bit of heat, start heating this up. Now what we'll do is put it on time lapse. Keep adding small amounts of nitric acid until we get all of this to dissolve. Glad I had this in this big beaker. That delayed runaway reaction went this high. It's only about 1.5 inches on the top of the beaker. So that's what I hate about this stuff, this DMG precipitate. It waits a long time. I had it on the heat for an hour, over an hour. And then all of a sudden, after I added that last about 2.5 milliliters of nitric acid, I get this delayed runaway reaction. Let's rinse down the inside of the beaker. Oh yeah, we came very close to the top of the beaker, man. I'm gonna add one more small shot of nitric. That's 1 milliliter. Just drop it in real slow. Goes. That just goes to show you why it's important to have this stuff in a much bigger beaker than you think you're going to need. I think I've pretty much got everything to dissolve here. I'm going to add another 0.5 milliliter, maybe even a little less. And if I don't get any kind of reaction here, that will be an indication that just a little bit of sudsing going on there. That tells me that we pretty much got everything to dissolve. Because there's nothing in there left to react with the nitric as I add it. So I think it's fair to conclude that we've got everything dissolved in there now. And what we'll do is just let this go until all those fumes clear up and all the excess nitric has been driven off. Got this all evaporated down. And now what we'll do is take it off the heat and let it cool down. I've cooled the solution off in an ice bath, and so now we're ready to filter our solution. If you remember earlier, I did a test with some ammonia, and you can see that it's turned blue. And that tells me that there was in fact some copper in there. So now what we're going to try to do, if I can pull this off, I've got a hand pump here, and we're going to try to filter the solution with a hand pump, because I don't want my regular motorized vacuum pump. It discharges into the space here, into my workspace, so I'm going to use this to draw vacuum on our flask, and the vapors will discharge into the fume hood, and we can they can be pulled out of the space. This ended up working out okay, I guess. Got a little bit of a workout. And the reason I did this is because my motorized vacuum pump discharges into my work area. And this, the discharge is on here, and it'll pull in fumes out of my work area. The little hand pump actually worked out pretty good for us. Now what we'll do is get our solution off of here. I'm going to add our solution to a beaker. Now what we'll do is render the metals out of this solution on pieces of zinc. Just going to drop them in, and in accordance with the reactivity series of metals, the zinc will go into solution as the platinum group metals come out of solution. Here we go with the first piece. I'm going to add in a couple more pieces of zinc here, and we're just going to let this continue to react until all that solution is cleared up in like a light grayish green color. And you can see how much metal we got going on down in there now. That black powder on the bottom there, that's our platinum group metals. It's been cemented out of the solution with zinc, and I think we're going to call it right here. It's getting kind of late, so we'll pick right back up with part 3 in the morning. This will conclude part 2 of the dental scrap recovery and refining series of videos. Thank you for watching.